So let's learn a little bit today about equivalent fractions and simplifying. So what does equivalent mean? Well, the equivalent, the word itself, means equal. So if obviously we're gonna go towards equal fractions. So I have 3 rectangles and they are all the same size. Now you'll notice that this rectangle is divided into 2 equal parts. Now remember when we talked about our introduction to fractions, the denominator tells you how many parts the whole is divided into. So we have 2 parts. So each part, in this case, is 1/2. All right, so what about this one? So this one has 4 pieces and 2 are shaded. So that means the denominator says divide the whole into 4 parts, and the top, you could say, is how many we have shaded. So 2 parts of 4 are shaded. And this rectangle right here, again, keep in mind these are all equivalent sizes. This is divided into 6 equal parts and 3 parts are shaded. So 6 equal parts, 3 of them are shaded. So what we can say, we can tell by the picture that the shaded parts are all equal. Well, how can that be? Because this one's 1/2, that's 2/4, and that's 3/6. Those can't be the same, can they? Well, in fact, they can be. By using multiplication, that's one way in which we can find equivalent fractions. So if I take 1/2 and I multiply both the top and the bottom by 2, notice that I get 2/4. Well, what if I multiply the top and bottom by 3? I get 3/6. 1 times 3 is 3, and 2 times 3 is 6. And so each of these, 1/2, 2/4, and 3/6, are all equivalent fractions. This is 3/5, so 3/5, and we want to find an equivalent fraction. Well, how are we going to do that? Well, let's multiply the top and the bottom by the same number. If I multiply the top by 2, so 3 times 2, and I multiply the bottom by 2, 5 times 2, I get 6/10. So what this tells me is that 3/5, or 3/5, is equivalent to 6/10. Now this is important. You have to multiply the top and the bottom by the same number. Here's why. Well, let's say I just decide, well, I don't want to follow those rules. I can find my own equivalent fraction by multiplying the top by 2 and the bottom by 3. So I multiply the top by 2, 3 times 2 is 6, and I multiply the bottom by 3, 5 times 3 is 15. So here I have 3/5. Same size rectangle. The top is divided into 5 parts. The bottom is divided into 15. So this is 3/5. This one is 6/15. Now, since these are the same size, the shaded part should be equal if we have equivalent fractions. But notice this rectangle on the bottom, the shaded part is actually less than the shaded part which is on the top. So in fact, it's this much less. So you have to multiply the top and the bottom by the same number in order to get an equivalent fraction. So 6/15 is not equal to 3/5. So we can use multiplication to find an equivalent fraction. Well, we can also use division to find an equivalent fraction, as long as same as with multiplication, we divide the top and the bottom by the same number. So 9/15, if we want to use division, what do you think we're going to divide by? Well, let's divide by 3. So 9 divided by 3 is 3, and 15 divided by 3 is 5. So what this tells us is that 9/15 is equivalent to 3/5. So that was finding equivalent fractions. Now let's talk about simplifying fractions. Simplifying means in a fraction, we're going to make it as small as we can make it. So 45 over 75. Well, I happen to know that 45 and 75 can be simplified by dividing the top and bottom by 15. So if I divide 45 by 15, I get 3, and 75 divided by 15, I get 5. Well, sometimes the numbers are really big, and it's hard to know if you've actually got it simplified. So there's something called prime factorization, which we have already practiced, but now we're actually going to use it. So 45 and 75, we're going to do our factor tree. And we know that 45 is divisible by 5. That's the easiest thing, our divisibility rules. So if I divide 45 by 5, I get 9. Well, that's much simpler now. 5 is a prime number, so 9 will divide by 3. So if I divide 9 by 3, I'm left with 3. So now we have only prime factors, so we're good with that tree. Let's look at 75. Again, 75 also is divisible by 5. So if I divide 75 by 5, what do I have left? I have 15. And 15 is divisible by 3 and 5. Now, 75 is now broken into its prime factors. So let's put it all together. So this was 45. We broke it down into its prime factors, and the bottom was 75. So now what we're going to do is we're going to cancel off 3 divided by 3 is 1. 5 divided by 5 is also 1. So here's what we have left. We can't cancel those guys. So 45 divided by 75 is equal to 3 over 5. How about 8 over 24? Let's simplify using prime factorization. Again, 8 is an even number, so let's divide by 2. And what do we have left? We have 4. And 4 is an even number, so let's divide by 2 again. And this time we're left with 2. So now we have only prime factors, so our factor tree is done. 24 is an even number, so let's divide it by 2, and we get 12. 12 is an even number, and again, we keep breaking it down until we get to all our prime factors. Okay, and so this is 8. This is what our 8 broke down into for its prime factors. And the bottom there is 24. So now we're going to cancel off. So we have a 2 on the top and a 2 on the bottom. That's the same as 2 divided by 2, which is 1. And here we have 2 divided by 2, which is 1. And here we have 2 divided by 2, which is also 1. Well, the top is all canceled off. Does that mean I have nothing there? No, it means that you have 1. And what's left on the bottom is 3. So we have 8 over 24 is equivalent to 1/3. And that is as simple as we can make it. And that is your lesson on equivalent fractions and simplifying.